Ants at a picnic. A family having a picnic went on a hike and left their picnic basket at the table. A colony of fire ants 600 feet north of the table spot the food and begin marching toward the basket at a speed of 4 feet per minute. At the same time, a colony of black ants 800 feet west of the basket begin marching at a speed of 5 feet per minute. What we need to find is 1. How long will it take for both colonies to reach the picnic basket? 2. Write a function to model the distance, d, between the two colonies of ants in the terms of time, t, that has passed since each colony has begun marching. 3. When the family returns from their hike, the ant colonies are 500 feet apart from each other. How long had the ants been marching? The formula we will use in order to find the distance between the ant colonies is the Pythagorean theorem, which is a squared plus b squared equals c squared. To find out how far the ant colonies have traveled, given a certain amount of time, we will be using the distance formula, which is distance equals rate times time. To determine how long it will take for both ant colonies to reach the basket, we will be using the distance formula. Because the red ants are 600 feet from the picnic basket, our distance is 600. They are traveling at a speed of 4 feet per second, so our rate is 4. We plug those numbers into the formula and find that t, time, equals 2.5 hours. Because the black ants are 800 feet from the picnic basket, our distance is 800. They are traveling at a speed of 5 feet per second, so our rate is 5. We plug those numbers into the formula and find that t, time, equals 2.67 hours. So it will take the red ants 2.5 hours to reach the picnic basket, while it will take the black ants 2.67 hours to reach it. Our independent variable is time because time cannot be affected by anything, while our dependent variable is the distance between the ants, because the distance between the ants is dependent on time. As time increases, the distance between the ants will also increase. To answer the second question, which was to write a function to model the distance, d, between the two colonies of ants based on the time, t, that has passed since each ant colony has begun marching, we will be using the distance formula, as well as the Pythagorean theorem. Before we can find the distance between the ants at a certain time, we must first find how far the ants have traveled at any given time. To do so, we will use our distance formula. For the red ants, because their rate is 4 feet per minute, the rate is 4. Time is unknown, so we will use the variable t for the time. Therefore, their distance traveled at a given time is 4t. For black ants, their rate is 5 feet per minute. Therefore, their rate is 5. Once again, their time is undefined, so we will plug in t for time, which means their distance traveled at any given time is 5t. Once we draw out our diagram, it can be recognized that a right triangle is formed. When we want to find the length of a certain side for a right triangle, we know the length of the two other sides. We use the Pythagorean theorem. However, we need to find the two lengths of the legs of the right triangle. So, for now, we will name them A and B. Earlier, we determined how far the colonies have traveled at any given time. For the red ants, it was 4t. For the black ants, it was 5t. We can remember that the red ants start out 600 feet from the basket. Therefore, their distance from the basket at a given time is 600 minus 4t, meaning one of the legs of the triangle will be 600 minus 4t. We use the same process to find the distance from the basket for the black ants. They start out 800 feet from the basket, and their distance traveled at a given time was 5t. Therefore, their distance from the basket at a given time is 800 minus 5t, which will serve as the other leg of our right triangle. Now that we know the lengths of both legs of our triangle, we can finally use the Pythagorean theorem to find the distance between the ants at any given time. We will plug in 600 minus 4t for A and 800 minus 5t for B, and solve for C. C represents the distance between the ants at any given time. Therefore, our formula is dt equals the square root of 600 minus 4t squared plus 800 minus 5t squared, which is the answer to our second question. Now that we have our formula, we can use it to answer our last question. To To find out how long the ants have been marching when they are 500 feet apart, we will be using our graphing calculator for this. We will type in our equation, square root of 600 minus 4t squared plus 800 minus 5t squared for the first y equals. Then plug in 500 for the second y equals, because 500 is the distance between the ants. Once you have typed in the equations, you need to set the window. Our x minimum is -3 because x represents time, and although time cannot be negative, we want to go a little outside of where we anticipate our intersection to be at. To find our x maximum, we just have to guess and check, and we decided to put our x maximum at 300. Our y minimum will be at -3 because y represents distance, and distance can't be negative. But again, we want to go a little outside of where we anticipate our intersection to be at. We know that our intersection's y value will be 500 because there is a horizontal line at y equals 500. Therefore, we set our y maximum at 600 to go a little outside of where the intersection will be at. After we have typed in our equations inside our window, we are finally ready to find the intersection. On your graphing calculator, hit the second button and then the trace button. Then scroll down to 5 and hit enter. The calculator will ask you to estimate where the intersection is. Then hit enter and you will find the intersection is at 78.2, 500. Therefore, the amount of time the ants had been marching when they were 500 feet apart was 78.2 minutes.